Hi, welcome to Chemistry Hoff. My name is Mrs. Hoff. In this video, we're going to be talking about scientific notation. You're going to learn what scientific notation is, why we use it, especially in chemistry. You're also going to learn how to write a number in scientific notation, and then how to write scientific notation back into a longhand form. There will be 2 practice problems at the end of the video. Hope you enjoy this video. Don't forget to like, comment, and subscribe. In this video, we're going to be looking at scientific notation. Let's get started. In science, scientific notation becomes a really useful tool. We often deal with numbers that are really, really large or really, really small. And when dealing with these different types of numbers, it is sometimes difficult to keep track of all the zeros, keep track of how large or small the number actually is, and be able to write it consistently when you're solving a problem. Scientific notation is a good way of allowing us to write these numbers in a more easily accessible and more succinct way. For example, if we're talking about the speed of light is 300 million meters per second. Now, that number can be sometimes annoying to write down over and over, especially keeping track of all those zeros. We can rewrite it, and we could say it is 3.0 times 10 to the 8th meters per second. Scientific notation, as you can see here, allows us to write the number with a little bit less work. It'll be able to allow us to compare numbers a little bit easier and also do math a little bit easier as well. Let's take a look at some of the different parts that are in our scientific notation. I like to think of scientific notation as having 3 main parts. The first part is my base number. So I'm going to go ahead and put my example that I had up before. And what we see is that if I'm talking about my base number, I'm talking about this number right here. So this right here, I like to think of as my base number. This number needs to be greater than 1, but it must be less than 10. Every scientific notation will also have a times 10. So here is my times 10. And it will also have an exponent. So you can see that in this example, my exponent is 8. This exponent can be positive or negative. This just tells you how big or small the number is. Is it a number that is less than 0, or is it a number that is greater than 1? When we are dealing with really large numbers, we want to make sure that we are moving the decimal to the left, and we want to note that our exponent will be positive. So let's take a look at that example that I used before and prove to ourselves that it is 3.0 times 10 to the 8th. My number was 300 million. I'm going to leave off my units for now. Now, if we think about where our decimal point would be in this number right here, it would be at the end. I want to move my decimal to the left, and I want to keep moving it and counting until it is after the first non-zero number. For example, here right here is my first non-zero number, my 3. So I'm going to go ahead and move it over. 1, 2, 3, 4, 5, 6, 7, 8. Because I moved it over 8 positions, this ends up being my exponent. My base number ends up being 3.0 times 10 to the 8th. Notice that my exponent is positive, and that's because my original number is larger than 1. If we think about moving our decimal place over, notice that each position that we move our decimal place is a factor of 10. That is where my times 10 comes from. You can prove this to yourself by plugging this into your calculator. If you plug in 3.0 and you plug in times 10 to the 8th, you should be able to get this number up on your calculator. What if we're dealing with really, really small numbers? So for example, what about this number? 0.0000956. Keeping track of all those zeros can be difficult. So what we want to do is we want to move our decimal to the right this time, and we want it to still be after the first non-zero number. If we look at our number, we see that our first non-zero number is the 9. So I'm going to keep moving my decimal place over until it's after the 9. Starting with my decimal, I'm moving it 1, 2, 3, 4, 5, 6. Now, because I'm moving my decimal to the right and my number is really small, this means that my exponent is going to be negative. So this is going to be negative 6. So again, to write this, I'm going to have 9.56 times 10 to the negative 6. And that is writing out my really small number for scientific notation. Now, when we're dealing with scientific notation, we also need to be able to write scientific notation back into what I like to call longhand notation. If the exponent is negative, we're going to move the decimal to the left, which means that we're going to be making the number smaller, and we're going to add zeros in front. Let's look at an example. Let's say that I have 2.14 times 10 to the negative 5th. Again, since it's negative 5, that means that this number is going to be smaller. I'm going to take my 2.14 and I'm going to take my decimal and I'm going to move it to the left 5 times. 1, 2, 3, 4, 5. And I'm going to put a decimal right here. Now in between here, I'm going to put zeros. So notice if I were to take that decimal and I were to count it over with those zeros now, I see that I have 1, 2, 3, 4, 5 places. Now to rewrite this, I'm going to have 0.1234 zeros, 214. Now, if the exponent is positive, I'm going to move the decimal to the right and I'm going to make the number larger and add zeros to the end. What if I have 4.534 times 10 to the 7th? Now I'm going to write down my base number, 4.534. And now, because it's to the 7th, I'm going to move my decimal 7 places over to the right. 1, 2, 3, 4, 5, 6, 7. All of these are going to be zeros. Let's go ahead and rewrite that number. Here's my number, 45,340,000. So we can see that we can write it back and forth. Let's go ahead and do some practice. Go ahead and press pause now, and the answers will show up in about 10 seconds. All right, here are my answers. For the first one, I have 3.45 times 10 to the 10th. Notice that my original number was larger than 1, so my exponent's going to be positive, and I can count over my decimal places. So if my decimal is at the end, I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that gives me my times 10 to the 10th. Over here, we can see that my exponent is negative, and that's because my number is less than 1. And I can get the negative 11 by counting over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can see that my answer is 6.5 times 10 to the negative 11th. Hope you enjoyed this video and it was helpful. Don't forget to like and subscribe. And leave a comment down below and let me know what video you might want to see coming up soon.